All right, we got Unit 3, Lesson 11, Splitting Triangle Sides with Dilation, Part 2. Okay, so in Activity 11.1, Notice and Wonder, looking at this image here, okay, they tell us that AC is parallel with line MN. Okay, so what do you notice and what do you wonder about this figure? All right, so hopefully you paused the video and you looked around. Yes, you have the two parallel lines that was given, but how many triangles do you see, right? So I notice um, got two triangles. All right, we have triangle ABC and triangle MBN, right? So I notice there's actually like got this smaller, more adorable triangle, right? As well as the much larger triangle. Okay. Now what else can I notice? What about angles? Have you guys looked at the angles yet? All right, so maybe that could lead us to something. So let's look at the angles just for giggles, okay? Okay. I notice again parallel lines. So what do we know about those two angles, right? So angle BAC is going to be congruent to angle BMN. Why? Because those are corresponding angles, right? Okay, that's something important to notice. Do we have something similar? Yeah, we have this angle congruent to that angle, right? So angle ACM or ACB, apologies, should be congruent to angle MNB. Okay, wait a minute. How many angles are there? There's two pairs of angles that are congruent to each other. What does that mean about these two triangles? Right? It means that triangle ABC is what to triangle MBN. They are similar by angle similarity. Angle triangle similarity. My bad. Okay. I feel like I've really talked about this. Okay, so yeah, I think that's what I noticed. I think I answered my wondering, right? Because like I noticed the angles. I was wondering about the angles, and then I realized, yeah, we got corresponding angles. We got angle. That means these two triangles that we identified here are similar. Okay, good. If you notice anything else, let me know for sure. I'm pretty sure I missed something, right? Didn't talk about everything. What did you notice? What else did I not mention? Okay, 11.2, prove it. Parallel segments. So, does a line to one side of a triangle always create similar triangles? Well, that's kind of what we were looking at last time, right? With the notice and wonder. Number one says create several examples. Decide if the conjecture is true or false. If it's false, make a more specific true conjecture. Okay, we can do a lot with that. So let's see. Parallel lines, right? Definitely parallel lines. So that means these two triangles also, like if you think about it, like in this image, we have two triangles, right? Notice how their corresponding sides are either collinear, right? Like MN, or I'm sorry, BM is collinear to BA, right? So, and then notice that BN, right, this little side right here, is collinear to BC, right? And then notice that MN, right, is parallel to AC. So that definitely kind of tells me that we are still talking about dilations, right? Like dilations is still attached to this. We're definitely dilating. Now, where are we dilating from? This point B would be our center of dilation, right? It pushes out or brings back in the points, MN or AC, right? Let's see. What else can we talk about? What else do you kids see? Right? Let's see. To find additional information you can be sure is true, label it in the diagram. Um, let's see. I definitely know about these angles, right? These are the corresponding angles. So that's very helpful to notice, right? And that's what gives us angle, right? Triangle similarity. So that's nice to know. Interesting. 3 says write an argument that would convince a skeptic that your conjecture is true. So let's see. MN is parallel to AC, right? We talked about that. Let's see here. What else can we throw in there? And then we do have those corresponding angles, right? So that does give us angle, right? Like we already said, angle's a thing, right? So MN is parallel to AC, right? That was given. 2, right? We know that angle BMN is congruent to angle BAC because, again, those are corresponding angles. You could say the same exact thing about angle BNM is congruent to angle BCA for the same exact reason for those other two angles. So that's a pair of angles, that's a pair of angles. So we could definitely say, hey, those two triangles, right? Triangle BMN is definitely similar to triangle BAC by, again, angle similarity, triangle similarity. There we go. Oh, no, there we go. There we go. Okay, good. Yeah, so we already know that angle's a thing, right? And we just basically proved it. This would definitely quell any suspicion or doubt. All right, how do we apply it, especially in terms of finding length, right? So in 11.3, the preponderance of proportional relationships. That's a fun word. Try to use that today. And just walking around, just look it up too. Make sure you understand the definition of it, but definitely try to use that in your normal vocab. That'd be an interesting word to best, to to just pull that word out of nowhere, and then your people are just like, what? Say that word again. All right, let's see. So segments AB and EF are parallel. All right, wonderful. Notice how we definitely have this whole, like, oh, it's perpendicular, right? Like AD is perpendicular to DB. Well, that makes that a right triangle. And we're going to find all the missing lengths. So I'm going to find uh, FB or BF, right? Like we don't have that. We don't have EF. I don't really have AE, even though that one's, not too bad to find. And we don't have AB. So I'm going to find those four lengths. I think AB is probably the fastest one, right? Because we're talking about a right triangle. So I'm going to use the Pythagorean theorem. So we got 3 squared plus 4 squared equals AB squared. Okay. 3 times 3, or 3 squared, is 9. 4 squared, or 4 times 4, is 16. All right, AB squared is just going to stay there for now. Let's go ahead and combine like terms. So we get 25. All right, how to get rid of a square, right? Square root both sides. And if you do that, all right, you end up getting plus or minus 5. But in this context, it's positive 5 only because length can't be negative, right? So AB is 5. Okay, good. Okay, so we found one of our missing sides. Let's find AE. Okay, let's go ahead and get AE. I notice that DE, right, minus AD will give us AE, right? Because they already have the smaller part, which is DA, or I'm sorry, yeah, AD or DA, which is 3. DE, the whole long piece, right? This whole long piece is 7.5. That means AE is 4.5. Okay. Nice. All right. Now how do we find these? Well, I'm starting to feel like, hey, can we still use scale factors? Like, isn't this still a dilation? Like, you know what I mean? Like, A was originally 3, but now it's 7.5 when it turns into E after it dilates, right? So, like, let's apply that idea. So, scale factors. We have 3 for AD times some scale factor, and that gives us 7.5, right? Like originally we were at 3, and then you multiply by some scale factor, you get 7.5, right? So 3 times what gives me 7.5? So division property, right? What do you get? Okay, so hopefully you took 7.5, you divide it by 3, and you get 2.5, okay? So maybe perhaps that's the scale factor. And if we apply that to finding BF, we can do that. All right, so BF, let's see, we have BD, which is 4, times our scale factor, and that should get us 12. Am I thinking about that correctly? Oh wait, my scale factor is not 3. Silly me bananas. Scale factor is 2.5, right? Let me highlight that so I make sure I don't miss that next time. Okay, we're talking about scale factor there. So BF is what? 10? So that's not BF. That's not BF. What I just did was I found DF. That means this whole piece right here is 10. That means BF is what? We have 10 for the whole thing. The small part is 4, so the other piece has to be 6. So that helps us find BF, which is 6. There we go. Making more sense. It's very much like a puzzle, right? Feels like a puzzle. All right, what about EF, right? The last piece right here. Can we use Pythagorean theorem? Yes, right? You could do 7.5 squared plus 10 squared, and then square root all that and get EF. What about if I applied the scale factor? Would I still get the same answer? So let's go ahead and follow that question, all right? Again, EF, right, squared is going to be 7.5 squared plus 10 squared. Okay. Let me get my calculator to knock out this 7.5 squared. And then 10 times 10 is 100. So let's go ahead and add the 100. I ended up getting 156.25. Okay. And then square root that, right? Let's see. And I end up getting 12.5. Now, for those of you who are like, what just happened? I was just using Pythagorean theorem. Now, one thing that we could try is what if we do 5 times that scale factor till we get the same thing, right? The 2.5. So 5 times 2.5, 5 times 2.5. How about that? You still get 12.5 for EF. So notice how I can use Pythagorean theorem, or I could just apply the scale factor. Which one was more straight to the point, probably more efficient? I would say using the scale factor, right? So that was an interesting trip on my favorite rocket ship flying through the sky. All right, let's see. Number 2. Looks like we're still trying to find length. Okay. And we're still trying to find the measurements here. Okay. So look at that. They did hide some information here. All right. They gave us this. They also told us that BD and FG are parallel. Ooh, they also told us segment EB is 2.5 units long. That's good to know. Now, the fact they told us that these two lines, BD and FG, are parallel, guarantees me that these two triangles that you see, the smaller triangle and the large triangle as a whole, are definitely similar. Again, for the same reason of angle, angle, right? So we definitely know we can work with some kind of proportionality involving these measurements. Can't use Pythagorean, right? But we can use a certain sense of proportionality. All right, so let's see what happens here. E.g., right, this larger piece is 12 units long. EB is 2.5 units long. That's a very horrifying 5. There we go. Okay. Nice. Nice. What's my scale factor? Let me give you a hint. BD was 5. But after a dilation, 5 becomes 15, right? Because remember, dilations are dilations have or create similar triangles, right? So 5 times what gives you 15? Hopefully you realize that's 3, right? So your scale factor for this is 3. Okay. All right, but that's not our answer. So EF, right? Let me get the line a little bit closer in here. EF. All right, so BE right, still has to multiply by the scale factor to give you EF. So 2.5 times 3 gives you what? 7.5? Okay. So EF is 7.5. Very nice. Okay, what about ED? ED is the smaller guy, right? Well, you're at 12. Whatever ED was, it had to multiply by the scale factor of 3, right? Because again, all the sides need to be using or applying the same scale factor. So what times 3 gives us 12? Right? 12 divided by 3 is what? So 4. Okay. So that can help us find the missing pieces. Is there any other missing piece that I did not see here? I feel like I'm missing one. Let me double check. EG. Okay, I think we're good. ED and EF were the only ones. Oh, okay. All right. Nice. So notice how we can use the scale factors here to get our missing sides real quick. Okay, that's good. So lesson summary. We have these two triangles, and there are proportionality statements that we can connect to these two similar triangles. So, for example, BG, right? And this is a proportionality statement here. Okay, so let me explain that proportionality statement. BG, if you guys notice, is this side of the smaller triangle, and that is to the dilation of BG in terms of GA. Okay, so this small side is to the medium side, right? The large side would be the entire piece, okay? So that's just something to notice. BF is, right? So BG to GA is proportional to BF, which is the small side of the other side, okay? Which is to the medium side of the other side, okay? So small to medium is proportional to the small to medium. Why are they proportional? Because they have to undergo the same scale factor, okay? Because if they undergo the same scale factor, which they should with dilations, you are being preserved with similarity by angle-angle triangle similarity, okay? And we're going to have more practice with proportionality statements as we move along. All right, have a beautiful day.